Hello everyone, I'm D. Lochen, studying in JNUH. Today I'll be explaining you about two problems related to KCL. So first, let's learn what actually KCL means. KCL is Kirchhoff's current law, which is also known as nodal analysis. So here we analyze a node because node is a point where more than two branches are joined together is known as a node, which is different from a regular branch. Here three branches are joined, three or more. So minimum point is three. So first, this is the main criteria for doing nodal analysis. So according to Kirchhoff's current law, the current flowing and the current entering the node is same as the current leaving the node. This is the law given by Kirchhoff. So let's begin with this question. So first, calculate the according to this question, calculate the node voltages in the given circuit and the current flowing in the each resistor. So we have to find the node voltages, which is node voltages. So in this question, there are three node voltages, and then we have to find the current flowing in each resistor. So we have to find the current here, here, and here. So totally we have to find uh, three currents and two node voltages, as this one is grounded because this acts as a reference point. So first, the current 5 amperes will be entering this node. So we have to apply KCL at this point. So after applying KCL, we can see that the current 5 amperes will be entering this node. So this gets divided as I1 and I3. So same 5 amperes is equal to sum of 5 and I1 and I3. So this is that. This is this equation, and from this equation we can find the node voltages. Uh, so we have to assume the voltage at this node is V1, and at this node the voltage is V2, and the reference node is grounded. So we assume it to be we take it as 0. So as this is grounded, so this is 0, this is V2, and this is V1 to find the current in this branch, which is V1 minus V2 by 4, according to Ohm's law. According to Ohm's law, which is I is equals to V by R. So V is a potential difference, V1 minus V2 by 4, which is I1. And here we have, and the current I3 is V1 minus 0 by 2, which is the potential difference by the resistance. So we get the I3 and I1. So next we have to apply, uh, one second. Next we have to apply KCL at node 2. So after applying KCL at node 2, the current entering the node 2 is I1 and 10 amperes, and the current leaving the node 2 is 5 amperes and I2. So I1 plus 10 is equals to 5 plus I2. So there's the same equation. After solving this equation, we get I2 minus I1 equal to 5. So to find the current I2, which is quite simple, so V2 is at higher potential and this is low potential. So V2 minus 0 by 6 is the current I2, and I1 is same as the previous one, which is V1 minus V2 by 4. So after solving this, we get another equation, 60 minus 5V2 minus 3V1. After solving equation 1 and equation 2, we get V1 and V2, which are node voltages 13.33 and 20 volts. After getting this node voltages, it's very easy to get the current flowing through each resistor. So to find the current flowing through each resistor is simply the V. To find, it's very simple. To find the current flowing through this resistor, it's V1 minus V2 by 4, which is the current I1, and V1 minus 0 by 2, which is I3, and V2 minus 0 by 6, which is the current I2. So this is that. We have completed question number 1. Let's go to question number 2. So in this question, we have to find the node voltages in the below circuit diagram. So there are three node voltages, V8, VB, VC. So we have to find these three voltages by using KCL. And then we assume this, and then these 3 points are at same potential. So they are known as equipotential. So these three branches are grouped together, and we can say they're grounded, which is 0 volts. This and these three power nodes acts as reference node, and we need to find VA, VB, and VC. So first we have to apply KCL at node A. So that node A, to find the current, to find the equations. So first the current 1 ampere gets divided into I1 and I2. So I1 is the current flowing through this branch, and I2 is the current flowing through this branch. So VA minus V ground volt. So there's a ground. So VA minus 0 by 2 is the current I1 plus VA minus VB by 5. So current flows from high potential to low potential. So we take VA as higher. So VA minus VB by 5. So it is current I2. So we both add. So we add this both, and then we finally get an equation in the form of VA and VB. And then next we apply KCL at node B. So after applying KCL at node B, the same current I2 gets divided as I3 and I4. So this I3, so to find I3, it's very simple. That's VB minus VC by 4. By using Ohm's law, we get this potential divided by resistance. Similarly, we find the current I4, VB minus 0 by 20, which is I4. And then finally, then we get an equation in the form of VB and VC and VA2, because VA is also in the picture, because we are using the same current I2. So we get an equation V in the form of VA, VB and VC. So we get an equation, and then finally we apply KCL at node 3, node C, which is this node. This is the same I3 current getting divided as I5 and I6. So by using Ohm's law, we get this. We find the current I5 and I6. So I5 is VC minus of minus 5, which is plus 5. So it's VC plus 5 by 1. And here it's VC minus 0 by 10. So uh, so we have found I5 and I6, and then I3 is same as the previous one. So then we finally get an equation in the form of VB and VC. So we get equation 1, equation 2, equation 3. By putting all these values into calculator, we find VA, VB and VC separately. So VA, VB and VC are the nodal voltages which we have found. That's it. Thank you.